Okay, greetings and welcome back. Let's take on unlucky problem 13. And I say it's unlucky because this is the type of problem that I think can do you real harm on an exam. Every time I start to talk about exams, I always try to give students some strategies for taking exams. Maybe some of you have them, maybe some of you don't. The number one strategy, as far as I'm concerned, is what I call triage. Let's look at a problem and see if it's going to survive or not. If it's not going to, let's move on. See if you're going to survive the problem more than anything else. Don't just start from problem one and move through it. You want to start the test by finding a problem that you know you can do. And find another problem you know you can do. You can't spend a lot of time doing it. You have to read it and go, yeah, I know how to do it. Yeah, I don't know how to do it. In fact, here's what you'll do. You read a problem. Either you'll say, I know how to do this problem, or you'll say, I don't know. But there's two categories for me in that I don't know. It's either, yeah, I don't know right now, but I think I can figure it out. That's dangerous. Or, I don't know and I don't think I'm ever going to know. Okay? The latter case, if you just don't think you're going to do it, and given that this is a multiple choice test and you ought to answer all of them, maybe right then and there, go take your best guess, however you read all the problems, look at the answers, try to deduce something, but make a quick guess, dispatch that problem and get it off the books. If you think you can do it, dispatch that problem and get it off the books. If you think you can do it with a little bit of work, save that problem for later. All right? Because if it's going to take you time to do some work and you're not necessarily going to get a payoff, hey, all the problems are worth the same points. Let's not spend a lot of time on one particular problem, not get any points, and then sort of have an opportunity lost for other problems. So this problem 13, this falls into that category for me. It gives you a histogram, it gives you a cumulative frequency histogram, and it says which of the following conclusions can be made from the graph. So let's go through these 5 conclusions, and let me do my own triage assessment for them. I'm going to skip A, because A is the problem for me. B says the median test score is less than 50. I know I can look at that and determine that answer. C says 60% of the students had test scores above 80. I know I can do that. D, if the passing score is 70, most students did not pass the test. I can do that. The horizontal, and E says the horizontal nature of the graph of the test scores of 60 and below indicates that those test scores, I'm reading again, the horizontal nature, what does that mean? I don't really know what that means, but I think I can deal with it, okay, and not spend a lot of time. The problem is with the A. A says there is a greater variability in the lower 20 test scores than in the higher 20 test scores. Okay, I'm supposed to be able to look at that graph and tell that. Well, I got to tell you, I know what 2 different data sets, I generally know how to assess whether one has more variability. Variability means that the data points are either separated from one another, or all on the right side or all on the left side. That will have high variability as opposed to a data set which sort of has a central tendency, sort of symmetric or maybe slightly skewed one or the other. Because the variability is the sum of the squared deviations from the mean. So if all the points are very far, if all the points are over here and the mean is there, all of these points have big deviations, that will produce a bigger variability than a symmetric-like curve. The mean is right here. All of the points have small deviations from the mean. But I cannot look at a cumulative frequency chart and tell that. I could tell that from a regular frequency chart where instead of cumulative frequencies, you have maybe relative frequencies, maybe better still, counts themselves. So for me to answer A, I've already spent 5 minutes talking about it, I would have to convert this chart in cumulative frequencies back to counts, which is what I'm going to do right now. Okay, let's knock off the other questions right now. The median test score is less than 50. No, it's not. If you look at a cumulative percent histogram, all you have to do is go across from the 50. Okay, that's where the median is, 50% of the values on one side, 50% on the other side. And that hits in one of the bars, one of the classes that are around 80. Okay, so the median test score is not less than 50, it's probably greater than 80. C says 60% of the students had test scores above 80. Let's go up from 80 and go across and go, no, only about 40% of the students had scores above 80, so that's wrong. If the passing score is 70, most students did not pass. Again, let's go up to 70, go across, I get 40, no, 60% of the class passed. So that's wrong as well too. And the horizontal nature of the graph of the test score is below 60, so yeah, I see what they're talking about, it's kind of low. Indicates those scores occurred most frequently. No, it indicates that they occurred least frequently. So let's try to do A. I'm going to try to do this as quickly as possible. I don't want to make this video too long. When I count up the number of bins or number of classes, I see that there's 14. So this is number of classes or class number, okay? 1, 2, 3, 4. Let me go into hyperspace. There they are, and let me write down the midpoints. Also in hyperspace. They go 35, 40, 45, 50. Okay, and there I've got the midpoints. Now what I want to do is I want to put down the cumulative frequencies. Cumulative freaks. Okay, this I have to be a little careful about because I'm pulling these numbers off this chart. I've done it already, so let me go into hyperspace and write down my assessments. Look, the first 3 charts, I'm calling that 5%. 5%, 5%, 5%, 10%, 10%. So let me write down what I think they are. Okay, so I'm back. What I did was just put a flat edge at the top of each one of the straight edge rather, at the top of each one of the bins and read across on the vertical axis. Now I don't like cumulative frequencies. I want to turn those into counts. 100% is 40 counts. Yeah, 5% of 40 is 2. So these are 2 counts, 2 counts, 2 counts, 4 counts, 4 counts, 6 counts. Okay, so I'm going to put down cumulative counts. Great, I'm done. There's the cumulative counts, but it's not the cumulative counts that I want. I really want to know the counts. Like I said, I'm spending a fair amount of time on this problem. Yeah, this problem could undo me if indeed I chose to do this on the test, and I might have. I would have done it at the end though. So let me write down the counts. There must have been a 2 to start off, then a 0, then a 0, then a 2 here, then a 0, then a 2, and a 2. And in that manner, let me finish these off. Now, let's go back to the problem. The problem says, is there or is there not greater variability in the lower 20 test scores? These are the lower. These are the upper 20 test scores. Right? Here are the test scores. Here's their number of counts and their associated cumulative frequencies. Okay, is there a greater number? So what I have to do now is to load this into stats, edit. This is the midpoints. This is their counts. I can then run one variable stats and calculate a variability or a variance. And when I do that, I've loaded this and this, and I've loaded this set of midpoints and this to get the upper. Let me see what I've got here. I just ran the lower and I get sigma, what should we call this? Let's call this S sub x is equal to 7.2, okay? And let's run back over to, I'm going to run one variable stats again here. I really am. Only I'm going to tell it that I have this midpoints in one list and this in the second. And when I calculate in the second list, and when I calculate that, I get S sub x is equal to 12. You can sort of see it. The only numbers in this data set are 0 and 2. This is a data set that has everybody stuck on 0, everybody at 2. The mean is 1/2. They all are going to have about as much deviation from the mean as they can. Versus this is a set of numbers, one of which I think I wrote down wrong here. I don't see how that could be 33. What did I write down? This is just 3, sorry. Yeah, I think it's just 3. All of which, you know, are there's space between 1 and 10, and there's everything in between the middle. So indeed, this has a higher variability than this. A lot of work in order to get that. The real lesson from this problem is, would you have tried to do that? I don't know any other way to do it. Would you have tried to do it early on in the test? Bad idea if you do. All right, let's move on to another difficult problem.